And I do record all of these meetings, so Mikhail will get a chance to review our session if he wants later on today. Takes me a few hours to get them processed and uploaded. But
great.
And let me know when you've sent that.
Yes, I'm typing. Could you bring your email address back up? It's David Cohen 1949.
Sorry, yes. David Cohen 1949 at gmail.com.
Cohen, not Cohen.
Okay.
Actually, I pronounce it Cowan.
Yeah, that's what I was clarifying.
All right, I'm sorry, I'm just having a little trouble with this. Hang on a second.
That's okay. It's good to always get at least one photo uploaded, because the first one is the hardest. After that, then you know how to do it, and my email pops up when you type the first two letters, so it's pretty easy to do after you get the first one done. Using an iPhone, or are you using an Android?
I'm using an iPhone.
Okay. You need to send it as an attachment, a large image attachment.
Yeah.
As opposed to making it, the body of the text of the email. So geospatial sciences. I can't say that I've ever tutored anybody taking geospatial science. But
yeah, I really don't need too much help with most of it. Like the mapping kind of stuff. The stuff I need help with is what we're doing pretty much is working with cosines to figure out meridional angles, and
I know what you're talking about now. I can definitely help you using the law of cosines.
yeah, see, and I have the law of cosines written down, but it's just so confusing because with the numbers that we're using with these, each one that you plug in, they're pretty large numbers. And
Well, I tell you what, while we are waiting for that photo.
It was sent probably a minute and a half ago.
Oh, I'm sorry. Okay, there it is.
And I apologize if my handwriting's a little messy.
No problem. I think I can probably zoom in a little bit and make out everything.
So for step one, we started by drawing the triangle and putting each point into place. The three outer points stand for N, North Pole, D for Denver, and S for Seattle.
Okay.
So we're using the law of cosines. The numbers that we get from, let's see.
Why don't we talk about the law of cosines for a moment?
Okay.
I think that's the best thing we could do. Rather than me trying to figure out how to apply your specifics, I think if I can teach you how to use the law of cosines to solve any triangle, you'll probably be in good shape.
Awesome. Well, thank you. I appreciate your help this morning.
Sure, no problem. All right. When you use the law of, there's two trig laws. There's the law of sines and there's the law of cosines. Have you run into the law of sines yet, or are you dealing entirely with the law of cosines usually?
Law of cosines, but then again, at the very end of this sequence of problems, when you have the big formula where you plug in like cosine A to cosine lower B.
That's the law of sines. That's the law of sines. So yeah, I was going to say that it's tough to solve a triangle without using the law of sines. Hold on a second, I've labeled this wrong. Excuse me. That's A, that's B, and that's C. Okay? Now here's what the law of cosines says. Any side squared equals the sum of the other two sides, and these lowercase letters means the length of the side. The larger letters means the angle. Okay? Minus
Right.
2BC, whatever these two letters are, go there, times the cosine of the angle opposite this side on the left side of the equation. So I can solve this triangle by using this law of cosines. Now, you will frequently see all three laws. In other words, if I'm solving for side B, then it's going to be a squared plus c squared, the other two, minus 2 times AC, and then cosine of angle B. And the third one, obviously, is c squared is going to equal a squared plus b squared minus 2ab cosine of c. Okay? Now,
All right.
let's put
Can you just
some
give me
numbers. Let's put some numbers in here.
all right, just 1 minute, please. I'm still trying to copy down the...
Okay, one thing here, you're welcome to make notes as we go. I have no problem with that. But you will get a recording of this. So
Okay.
it might be easier for you to do your note taking when you're watching the recording. You know, you can stop it, you can pause it, write down all the formulas. In other words, there's a couple of different ways you could go.
So for this morning's session, David, Mikkel has a test coming up at noon.
Ah, okay.
So
I got you.
probably, yeah, it'll be a little different.
He won't have time to wait for the recording then.
Well, I mean, if the recording was sent right off right after this presentation, my class isn't actually till 12:45, and I get down there at 11:30, so I could spend a good hour.
Problem is when I record it, it's not viewable until I process it. And my computer takes about an hour to process a section, and then it takes me maybe 5 minutes to upload it to a YouTube file, and then you can go directly and view it. Whereas you don't have the software to view the original recording, which is in GoToMeeting format, but your join GoToMeeting software doesn't allow you to view the files. So that's the only problem with that.
David, do you have a hard stop at 10 o'clock today?
I'm sorry, what?
You have a hard stop at 10 o'clock today.
I do not.
Okay, so we could continue a little longer if needed.
Yes, I got your note that you might need up to 2 hours, and that's fine. I'm prepared to give you up to 2 hours. Although I don't know that we'll need it just to cover the law of cosines. So where there's two kinds of triangles. Every time you have a triangle and they give you 3 pieces of information, like this one, I know this side is 6, this side is 8, and the angle, the included angle is 60 degrees. Well, sometimes if you have 3 pieces of information, you can solve for the other 3. There's 6 pieces of information when you solve a triangle, and that is all 3 angles and all 3 sides. Well, sometimes you can use the law of sines, which is a little easier to solve a triangle, but when you have side, angle, side, in other words, you do not have an angle and its opposite side. I don't know what angle A is. I don't know what angle B is. But I know these 3 pieces of information, and using the law of cosines, I can solve for the side C. So if I were to do that on this particular picture that I've drawn, C squared would be equal, well, A squared is 6 squared b squared is 8 squared minus 2 times 6 times 8. And I do know that angle is 60 degrees. Okay?
Wait, I'm sorry. At the beginning of that last sentence, c squared is equal to b squared?
A
Well,
squared.
we're going off of this formula right here. We're going off the third version of the law of cosines.
So this is the formula, and all he's doing is inserting the numbers. So A, you know, is
A is
6.
opposite angle A. So that's why I know that this is side A, the 6.
So this is the angle. The opposite side of the angle is little a. So he could have written little a over there, but he's assuming
That's a little a.
no, that side of the triangle is little a for the purpose of the formula.
Yeah, here, let me label it also. Well, I don't want to label it like that.
Let me just
There's
so this
B and
little b,
with
that's
the
opposite.
little letters represent the lengths of the sides of the triangles. The big letters represent the angles that make up that vertex of that triangle.
Right, and so where did the 8 and the 6 come from?
So the opposite of this angle is this side, right? Do you understand that?
Yes.
Okay. So when you have a side that's the opposite of an angle, that side is automatically the little a in terms of the formula. So you know this side is little a, so he has a 6 there, and he's put it into the formula. And the same is true for b. This is big B, little b is the opposite, and there's an 8 there in his example. So instead of having the formulamatic a and b, he just put 6 squared plus 8 squared, because for this triangle, those are the length of the sides.
Okay, and so it doesn't really matter where like A, B, or C the uppercase ones are.
No,
Because
in fact, I drew another triangle down here. Okay, and this is the classical model of a triangle. You have letters at your 3 vertexes, and the small letter is opposite the angle.
So the letters could be any letters you want.
Okay, I got you.
In order. They don't have to be. Notice that I got A, C, B here. The only important thing is that the angle A be opposite the side A.
Okay.
Okay? So that's, let me erase this. And since we were trying to solve for side C, in other words, that was the first step of our process, we have the ability to solve for side C using the third formula that I wrote. First of all, look at these 3 formulas. Do you notice the pattern? In other words, if I have an A on the left, then I'm going to have a B and a C, and a B and a C, and a cosine of A. If I have a B on the left, then I'm going to have the other 2 letters here, those same 2 letters there, and it's going to be the cosine of the angle B.
Can you hold on 1 second? Oh, there we go.
Okay. Why do you keep doing that?
Because I try to.
It looks like I got a little note saying you want to be the presenter.
He was trying to make a certain part of the screen disappear, and I hit the wrong button.
Okay. There is a toggle switch on that control panel that's worth using that minimizes it. If you go up near the X, those 2 little arrows to the left of the X, if you click on that, then the GoToMeeting control panel will minimize so that it doesn't cover up much of your screen.
Oh, no, that's fine. It's not a big deal.
And it's a toggle switch. I've got mine minimized right now because it does cover up a significant portion of your screen. You don't want it blocking what you're able to read off of my screen.
Okay. And David, I don't want to take you too far afield, but I'm wondering if we could, now that you've explained that to Mikhail, if we could use the example on the picture that was sent to you.
Yes, we can, although I think it's important to finish this problem.
Okay.
And it's just a couple of steps, okay? In other words, now we've got c squared equals 36 plus 64 minus 48 times 2, 96. The cosine of 60 degrees is 1/2. So c is going to be the square root of 100 minus 48. C will be the square root of 52.
All right, I'll need a minute to copy this down real quick.
Well, you can copy it down if you want, but more important that you understand it.
Yeah, it's just, I'm sorry,
Especially especially if you have a test coming up. It's really critical that you follow my logic all the way down to the last.
Yeah, I'm sorry, it's tough to...
Not necessarily.
Okay, so let's start over and let's just go step by step. So, do you understand how little a, little b, big C, little c gets determined?
Yeah, I understand that the
Actually,
uppercase
the problem started out giving you little a, giving you little b, and giving you angle C. All of those were given. You have to have at least 3 pieces of information of a triangle in order to solve the triangle. Okay? But that's all you need is 3 pieces. If you get either 2 sides and an angle or 2 angles and a side, any 3 pieces will allow you to figure out all 3 sides and all 3 angles.
I understand that. It's just I need to just kind of look at it for a few seconds or a minute or two to kind of...
I don't want to hurry you at all.
All right, thank you.
Sure. Yeah, go through each step starting from that general formula right there.
And those little 2's above the lowercase c, a, and b in that first...
That's squaring it.
Squaring, right. Okay.
That's a squared, b squared, c squared. And that's why I did 6 squared, which is equal to 36. And 8 squared is equal to 64. But notice that what I'm getting on the left side is still c squared. So to get c, I had to take the square root of the right side of the equation.
Okay.
Now, by solving for side C, I can apply the law of sines and figure out this angle here, angle 1 or angle B, and angle A. Then I will have all 3 sides and all 3 angles. And I suspect that whatever kind of problems you're going to give me on paper, that's the eventual goal. In other words, once you draw your triangle, you have to solve it.
Right. See,
solve it using combination of the law of cosines combined with the law of sines. Now, we haven't gotten to the law of sines part yet, but we can. It's hard for me to imagine that in this class you're only going to have to use the law of cosines.
Yeah, so for the biggest problem I'm concerned about is they give us 3 outside points of a triangle.
Okay.
And instead of giving just A, B, and C, they label them the first one North Pole, the top one North Pole, like one of the bottom ones Denver, and then the other one Seattle.
Okay.
And we're supposed to use the law of cosines to figure out the shortest distance between Denver and Seattle, the lower two corners of the
Okay. All right. So
pyramid.
all you're doing is taking your model, North Pole, Denver, and Seattle, and you're going to make a triangle out of it and
Right.
solve the triangle. That's essentially what your job is. Okay? Well, in your drawing, let's go ahead and have a look at your drawing. We still didn't quite finish this problem using the law of sines, but let's put that off until we see whether you need to do that. You may or may not need to use the law of sines in this. It's hard for me to imagine that you wouldn't use the law of sines, but now, so if that's the North Pole, that's Denver, and that's Seattle.
Correct.
What other information did they give you? In other words, do we know the distance between N and D?
N and D on the outside, it was lowercase c.
Do we know the distance between the North Pole and Denver?
So how to find that? I'm supposed to take the North Pole and subtract the
Denver?
Yeah, to Denver, I'm supposed to subtract.
This is Denver latitude and longitude. Is that what that is?
Yeah.
Okay. I am not familiar with figuring out the distances based on latitude and longitude, so if you can explain that to me, we'll figure out how far it is from the North Pole to Denver.
Okay. Let me just skim over my notes real quick.
Okay. Let me move this. I guess the North Pole is, what, 0, 0?
Yeah, if you go, where is it? If you go to the bottom right section of the page, there should be it's called step 4, finding the meridial distance between Denver and the North Pole and Seattle in between the North Pole.
Okay. So have you done all that work? Can we dispense with that? And do we know some distances?
We can work with this work because this is all correct because we went over this in class.
So tell me what the distance is. Okay, so you got A equals, and let me look at your picture again because, okay, so you got this as A, this is B, and that's C, and that's fine. There's no problem using different letters other than the same letter of the angle that it's opposite. And your distance for A is 1018.
Yep.
Your distance for B is what? I see a B here, but I don't see a number next to it. In other words, we're going to figure out all three of these sides. Once we figure out all three of the sides, then I can figure out what angle D is. And that's what you're going to need. Is
okay.
D. We'll tell you how to get to Seattle. So
to find the little case B, my notes say to subtract 90.0000 north, which is the North Pole.
Okay.
Subtracting the latitude of, latitude's the smaller one, right? Not 105. Longitude
Another
105.
thing I do not have expertise in is latitude and longitude. Let me think for a minute. I know this. Longitude are the horizontal, latitude are the verticals, I believe.
Longitude is vertical from pole to pole.
I know that, but is longitude higher numbers or lower numbers?
It depends. Longitude is the same at the equator. The latitude of the equator is the same as longitude.
Generally speaking, usually it's like 105 to a 40-degree difference.
I don't know.
Okay, so
looks like you've taken the latitude minus the latitude from this note I'm looking at right here. And you got 42.3938 degrees. How do we convert that to a number of miles?
I'm not exactly sure. I think that's how we plug it into cosines.
So you're telling me that's an angle. Is that the angle of n?
Of n. Oh, yeah, I believe so.
In other words, we started with, so you're saying this angle right here is 42.39 degrees. Angle n.
Right, but I just, this is,
Now, all
because
I need is one more piece of information, either an angle or another side, and I can solve this triangle for you. But
okay,
I have 3 pieces of information. And
for
right now I only have 2. I have side A, and I have, presumably that's angle N, but I don't even know that for sure. That's where you're going to have to help. In other words, I can help you with the math part, but I don't know the geospatial science terminology well enough.
Quit. I know you didn't. This isn't. You were saying you didn't know too much about the whole latitude and longitude thing. But after a coordinate, if it has an n behind it, is that lat or lot longitude? Do you know?
No, that N means north. In other words, Denver's longitude is 39 degrees, 49 minutes, and 0 seconds north of the equator. Its latitude is 104 degrees, 59 minutes, and 0 seconds west of the meridian.
Okay, so no, that makes sense. I got it.
Now, what we do with that, I'm not sure. We've also got Seattle's north of the equator, west of the meridian, and the latitude and longitude of the North Pole is 90 degrees is the latitude, and the longitude must be 0. Has to be for the North Pole.
Oh yeah, we only worked with one number, and
Right.
I believe it was the latitude.
In other words, if you go up to the equator, there is no latitude lines. It's all one point.
Longitude.
It's all one point. You only have latitude when you're away from the poles. In other words, when you're at some longitude other than the North or South Pole, then you also have latitude. You know, the difference between Denver and Seattle is primarily latitude difference.
Right.
So, it seems to me we should be able to figure out all 3 sides and not have to deal with the angles, but I'm not sure. I just, like I said, I don't have that much expertise in this. I can solve any triangle you want to give me, but I got to have 3 pieces of information. So I either have to have all 3 sides. Seems like we should be able to come up with that.
Yeah, wait, which sides do we already have? The angle at
Just A.
At north?
Well, I'm not sure we do. I'm not sure that's actually whether we have that. I should erase that because I'm not sure that that's true. I don't know the geospatial science to figure out what that angle is. It's hard. Perhaps that angle is as simple as subtracting the, I don't know. You're going to have to tell me that. How we come up with all 3 sides, or give me 2 sides and 1 angle, and I can solve the triangle.
So we know we can get the distance between Seattle and Denver, right?
We've got that. How did we get that? Because if we can get that, we should be able to get the distance between the North Pole and Denver and also the North Pole and Seattle. So
the
come up with the 1018.
The 1018 was the shortest distance from Denver to Seattle, and that was the ultimate thing we were trying to get to.
Was that given to you, or did you solve for that based on their latitude and longitude?
We solved it through all this basic latitude and longitude. So like for upper class A, I would be subtracting 122 I have to convert this the longitudes and latitudes into decimal degrees before we can solve it.
It looks like here we got Seattle minus Denver's latitude. Okay, so Seattle's latitude, Seattle's latitude is 122. And Denver's latitude is 104. So we came up with this angle 17.3488 degrees.
Right.
Now the question is what do we do with that number?
So for that number,
go ahead.
I believe we plugged it into a cosine. Cosine, it's as the cosine formula goes, it goes cosine plus Sin.
That is the identity for the cosine of 2 angles added or subtracted together. In other words, if I have the cosine of A plus B, then the identity is cosine of A, cosine of B, plus sine of A, sine of B.
Yeah, so my formula read pretty much, just to break it down, it went cosine A equals cosine B times cosine C plus sine B times sine C times cosine A. And that's the formula.
Here's the problem. Well, I'm not familiar with this formula. And in fact, I'm not familiar with this cosine divided by cosine. There's a law of sines that says the sine of angle A divided by A is equal to the sine of angle B divided by B is equal to the sine of angle C divided by C. But there's no such law for cosines, not that I'm aware of. So, but remember once again, all right, so these steps were given to you by the teacher. Draw the triangle, convert Seattle to decimal degrees.
Right, so right under that for Denver you can see the latitude and longitude, but right next to it Oh, wait.
And then I'm subtracting Seattle's latitude. No, these numbers don't differ by very much here.
Yeah, this teacher hasn't been too
Question is, if we knew what to do with the difference in latitudes, in other words, the difference in latitudes between Seattle and Denver is 17.3488 degrees. That should be easily converted to miles if you know the total latitude change. And then you need the longitude to figure out how high up on the sphere you are. So the miles between Seattle and Denver have to do with not just the difference in latitudes, but also the difference in longitudes. It's some combination, is my guess. See what it looks like you've written over here? That's like the law of sines, only you used cosine instead of sine, and you can't do that.
Okay.
What does this line here say? 24,000, that's the circumference of the Earth. Divided by 360 tells you that if you are at the equator, oh, that's where you got the 1018.
Yeah.
Oh, because you multiplied it by 14.738. Where'd that number come from?
You know, to be honest, I was just copying notes off the board, and this teacher goes through it so quickly and then erases it before people have
In other words, I can see where you get the latitude difference. There's the 17 degrees. And I can see where they've taken the circumference of the Earth and divided it up into 360 degrees. So that number must be 1018. Here, let me use my calculator real quick here. 24,874 divided by 360. Ooh, that gives me 69, and then you multiply it by that number, 14 point. Anyway, 69 miles per degree if you're at the equator. In other words, if you take the circumference of the Earth, that number there, and you divide it by the number of degrees that latitude splits it up into, 360 degrees from the meridian, then you end up getting 669 miles per degree of latitude. And since, you sure you didn't maybe copy this wrong? In other words, it looks to me like you've taken this difference in latitude here.
Yeah, that's supposed to be Denver or Seattle minus Denver's latitude.
Right, and it is 17 degrees. But then how do you get this 14 degrees over here? Because there's a difference in longitudes. What's the difference in longitude between Seattle and Denver? 14 degrees. Okay, now we're getting somewhere. No, it isn't. It's 17 degrees.
Yeah.
The difference in longitude is only about 8 degrees. So how do you take the difference in longitude combined with the difference in latitude to come up with the miles between Seattle and Denver? Somehow we got to figure out how we came up with this 14.738. If we can figure that out, then I think we're in business.
Yeah, I'm
I don't understand this equation here at all. Well, first of all, you got to have an argument for a cosine. You can't just write COS, has no meaning. So
Yeah,
we're always
I
trig functions of angles. So we need an angle here. I don't know what it is. We don't know any of those angles yet. Where'd the number 0.4764 come from?
I don't know. I was copying that off of the board at the last minute of class, hoping I could figure it out later.
Yeah. I'm sure there's a formula for taking the latitude difference and the longitude difference and converting that to a number of miles. Trying to think of what it would be. Let's just talk about the Earth. I don't draw a very good sphere, but there's the Earth, okay?
Okay.
And there's the circumference, or there's the equator. And I'll draw out the equator in the back also. Latitude lines go like this. Okay? Longitude lines go like this. Should have drawn them in a different color. So at the North Pole, you don't have any difference in latitude. They all converge to a single point, all of the latitude lines.
Right, and isn't that 90?
That's the yeah, that's 90. So the North Pole would have a latitude of 90 degrees, and that measurement is basically if you draw an axis through the pole from the North Pole to the South Pole, it's going to make a 90-degree angle with the equator.
So, yeah, I kind of understand that, but with like, what was the one we were just talking about? Lowercase b.
Hold on, let me just finish my thought here. Let's see. So if we have Denver here and Seattle there, then we know their difference in latitudes because there's a latitude line going through Seattle, and there's a latitude line going through Denver. Can you see that if they were both on the equator, it would be quite easy. We would just take the number of degrees difference in their latitude, multiply it by this number we got, 61 miles per degree, and we would have the distance. But the higher up in the northern hemisphere that you are, the closer these latitude lines become. In other words, if I took the difference in latitudes between those 2 points near the North Pole, it would not be nearly as much as if I took it on the equator. It's expanded considerably on the equator. If I draw a ring around here, the circumference of that ring is not going to be anywhere near 25,000 miles. It's going to be 1,000 miles or so. So somehow we have to have a formula for calculating distance based on latitude and longitude. It doesn't surprise me that there's one out there. It's just I'm not familiar with what it is. But it would yeah, somehow I just don't know. If I thought about it for an hour or so, I might be able to come up with what that formula is. Based on what we know each degree of latitude is on the equator. But we're not on the equator. We're north of the equator. So we obviously have to take longitude into the equation. And in fact, we have to take their difference in longitudes because what we're looking for is this distance. Okay? And,
Yeah.
and that distance is going to be a function of their difference in latitudes and their difference in longitudes. I can see where the math might be a little bit greater than I've probably dealt with, at least in tutoring high school trig. Even if they had the same longitude. In other words, let's say that Seattle was there, because they have longitude other than 0, they're not going to be 61 miles per degree of latitude apart.
Right.
But you could almost figure out through some sophisticated geometry. In other words, the equator around the center of the sphere is 25,000 miles, but if I drew a circle around halfway up, that's not 25,000 miles anymore. In fact, if I go all the way to the North Pole, the circumference of the circle is 0, if you can see that. In other words, if I draw my circumference lines like this, that's not 25,000 miles anymore. It's beginning to look like a pumpkin, isn't it?
Yeah.
And the further I go up on the planet, the smaller that circumference becomes. And
Okay.
what we would really want to do is figure out, well, like I said, I'm just not familiar with the geometry of solving for distance based on latitude and longitude.
I understand.
We can't, we're going to have a hard time progressing until we get that.
Yeah,
Now,
and I'm going to
if
talk to
that's
my
something you
professor.
can figure out apart from me, then I can take you to the next step, which is once we get all 3 distances, we can solve for this angle, D. Because you need to know what direction to go, right? The question here is not just how far is it between Seattle and Denver, or is that the question?
It's the shortest distance between Denver and Seattle.
Okay, that's all we need to solve for. Then we don't. Oh, I see. There must be there must be sines and cosines involved to convert these latitude and longitudinal differences into distances.
Yeah, and the other thing is all the latitudes and longitudes need to be changed into decimal numbers before we can find the meridional angle, which is
Okay, well, that I can help you with.
and that is subtracting longitude from longitude.
Let's take Denver's longitude. Okay, 39 degrees, 49 minutes means 49/60ths of a degree. You see why? There's 60 minutes per degree.
Oh, yeah, I got 39 degrees, 49 minutes, 00 seconds.
Right, but the 49 minutes is a part of a degree. It's 49/60ths of a degree. If I divide 49 by 60, hold on, I get 0.816. So Denver's longitude is actually 39.816 degrees. That's what they mean by converting it into a decimal degree.
39 point what?
0.816. In other words, when it's in degrees, minutes, and seconds, what this means is there are 60 minutes to a degree, and there are 60 seconds to a minute.
Yeah, yeah, I understand that
So
part.
when it says 49 minutes, it really means 49 divided by 60 degrees. So we have
Right.
39 degrees plus another piece of a degree, 49 over 60th, which turns into 0.816. So Denver's longitude is 39.816 degrees. Okay, and that's why it says convert
In
Seattle
decimal
to
degrees?
decimal degrees. And
Okay.
did we do that? Yeah. Seattle comes in, oh no. Seattle comes in at 104.98. Notice that Seattle was 104 degrees, 59 minutes. That's 59 divided by 60 degrees. You understand that?
Yeah.
Okay, so that's how this
Oh
latitude,
no, that's Denver's latitude.
that's Denver's latitude, and it converted to 104.9833. In other words,
So
59 divided by 60 is 9833. 0.9833.
okay, I'm sorry. Can you just go over the division thing one more time between those two problems?
Sure. Seattle was, hold on. So if we're converting Seattle's 122 degrees, 33 minutes, 21 seconds. Here's how I'm going to convert that to a decimal. That's 122 degrees plus 33 divided by 60 degrees plus 21 divided by 3600 degrees. In other words, 21 seconds, there are 60 seconds per minute, 60 minutes per degrees, so there are 3,600 seconds per degrees. So what I'm doing is taking that number of degrees, I'm converting that to a part of a degree, and I'm converting that to a part of a degree.
Okay.
Add these three numbers together and you'll have the decimal representation that they get, which is clearly 122.3321. Oh, no, that's not correct. That's just using the same, that hasn't been converted to decimal yet. You see that?
Yeah.
This number right here reads exactly the same as the latitude number. 122 degrees, 33 minutes, 21 seconds. Well, that's not what you get when you do this math. Here, let
So that's
me tell
not
you
the
what
decimal
you get. Let me tell
degree.
you what you get. When we're converting 33 divided by 60 is 0.55. So this number is 0.55. 21 divided by 3,600 is 0.00558. 0.0058 rather. Now if I add these three numbers together, I'll get that. I get 122.5558. That's what Seattle's latitude is when converted to decimal. Let's see if we can find that number anywhere on your page.
Well, I found the previous number,
Yeah, you
and
got Denver's converted, or yes, this is Denver's latitude converted properly. because Denver's
Right.
latitude was 104. See, this designation isn't right. Here's Denver's latitude, 104 degrees, 59 minutes, 0 seconds. Let's go through that. 104 degrees, 59 minutes, and 0 seconds. Okay? So how do we convert that to a decimal? You did it properly. Down here, I can see that you've got it 104.9833. But it's not 104 degrees, 98 minutes, which is impossible. Maximum minutes you can have is 60. 33 seconds. Well, I get that number down here by doing this. It's 104 plus 59 divided by 60, because there are 60 minutes in a degree. Remember, what I'm trying to do here is convert each of these to degrees. So that's 104 degrees, that's 59/60ths of a degree, plus 0 degrees. And if you do 59 divided by 60, you get 0.9833. So this whole thing converts to 104.9833 all degrees. No more minutes, no more seconds. So when you wrote this down here, you want to erase those minute and second hash marks and put a decimal right there. I don't know if I'm pointing or not.
I just don't understand how you get 98.33 out of 59 over 60.
What does that come out to be? 0.9833. Do you have a calculator in front of you?
59 over 63?
No. 59 over 60. Divide that in the calculator. What do you get?
60?
What?
One sec. I'm looking at my calculator because I don't know. I just don't understand it.
Well, just do it in your calculator and see what you get.
All right. So
59 divided by 60.
Oh, okay. Now I got it.
Okay. And if we had some number of seconds, we would have to convert that to a part of a degree. Well, on the Seattle problem, that's what we had. In other words, when we were figuring out I haven't quite figured out this problem yet. Must have been on this page. Yeah. Here we had Seattle's latitude, 122 degrees, 33 minutes, 21 seconds. So the 33 minutes has to be converted to a amount of degrees. So does the 21 seconds. Well, 33 divided by 60 is equal to 0.55. We divide the number of seconds by 3,600 because there's 3,600 seconds in a degree. There's not 60. There's 60 seconds in a minute, but then there's 60 minutes to a degree, so you end up with 3,600 seconds per degree. And we got 21 seconds, so we have 21 divided by 3,600. And that should be labeled, that's how many degrees there are. Add all three of those numbers together, 122 plus 0.55 plus 0.0058, and you get this number right here. Okay, so now you should know how to convert degrees, minutes, and seconds to decimal degrees. That's what we just did.
Yeah.
Okay, so now the part that I don't know how to do that somebody needs to figure out how to do before you get into this test is to take the decimal latitude and longitude of Denver and Seattle and figure out how to figure out the distance between them.
Okay, so how my teacher explained this
Okay.
was we have a cosine formula.
Okay, what is it? What's the general?
So it starts with cosine lowercase a.
Okay.
And then it says equals, parentheses, cosine lowercase b. Parentheses, close, or what is it? Cosine lowercase c.
Ah.
In parentheses, plus sine lowercase b, sine lowercase c, and then cosine capital A.
Then cosine of A. Wow.
A capital A.
Yeah, that does sound like the law of cosines. Let's see if I can figure out how that is. Because here's what the law of cosines would say. A squared equals B times C minus 2B times C cosine of A. Notice how similar those are. Oh, excuse me, I didn't write it right. Yeah, they're not that similar. I was being with B squared plus C squared. I think we can figure this out, though. First of all, what this is the identity for cosine of B minus C. If I wanted the identity for the cosine of B minus C, it would be cosine of B, cosine of C, plus sine of B, sine of C. And that's what I've circled there. So
okay.
I could say that, let me see if I can work out the math here. So I got the cosine of little a equals, and in place of what you've got, I'm going to write cosine of B minus C, and then cosine A. So the cosine of B minus C must be equal to the cosine of little a divided by the cosine of big A. And that puzzles me, because what's the cosine of little a? You have to take the cosine of angles, not sides. And according to your drawing, little a looks like the distance between Denver and Seattle. That's a side, that's a length. That's in miles, not in degrees.
Right. What I was saying is to find the miles, we have to plug in all these formulas into the long formula of cosine.
Why do we have a little a and a capital A?
Because if you can look at the picture a little bit, the lower a on the bottom,
that's the
significance.
That's
distance
between Seattle and Denver. You can't take the cosine of a distance. So saying cosine little a doesn't make any sense.
Okay, well, that's honestly the way I was taught in class today. So I'll tell you what.
I'm suspecting. Well, no, I don't know, unless there's higher trig going on here because curvature of the Earth or something. I don't know. I'm familiar with a lot of these formulas regarding the law of cosines and regarding these identities, but I don't quite see how you end up with what you've written over here. Plus, how do we know what the cosine of B is? We don't, in other words, the formula you gave me, we don't have any of these numbers. We don't know any, we don't know the angles, we don't know sides.
Right, and what he wanted to do was, what he was explaining what we need to do is find the elevation and the longitude of places like the North Pole minus Denver, like the North Pole.
Oh, so you're saying that B and C must be like the difference in latitude and the difference in longitude, perhaps. In other words, we know how to do that. We can figure out the exact decimal difference in latitude between Denver and Seattle, and we can figure out the exact decimal difference in longitude. And between those two things, we should be able to figure out distance.
Yeah.
Let me draw a picture here and see if I can, let's see. If I had, I can't even think of how I'm going to do this. We got Seattle there, we got Denver here, and the difference. So Denver's latitude is 104, Seattle's latitude is 122. Then I'm rounding it off just to help me. Denver's longitude is 39. Seattle's longitude is 47. So that gives us kind of a good understanding. Seattle is 18 degrees west of Denver and 8 degrees north of Denver. Okay? Again, I'm rounding it off just so maybe we can get an idea here. Well, what happens if we draw this triangle? Does that mean that's an 8-degree angle? Probably does. And no, because that would not be the right angle there.
I don't know. I actually I have class around 12:45.
Yeah.
So I might just head down a little early and try to go over this.
That's fine. That's fine. I hope at least I've helped you show you how to convert latitude and longitude into decimal degrees.
Yeah, you've definitely helped me a lot this morning. I really appreciate it. And
I would say the next step that you really need to give your attention to is to how to take a latitude and longitude of Denver and a latitude and longitude of Seattle and figure out the distance between them. What formula is required there? I know you subtract the latitudes, so there's 18 degrees difference there and there's 8 degrees difference there. That might allow you to solve this triangle so we could come up with this distance x, which would be the distance between Seattle and Denver. I don't know what the formulas are. If you can get the formulas and apply it to this picture, I think you'll be miles ahead of where you're at right now.
Okay.
Once you figure out that technique.
Oh, well, I really appreciate your help this morning. And,
I'm sorry I couldn't be more helpful.
No, it's fine. Like I said, it's like, you know, geospatial sciences.
Yeah, it's definitely a little different than what I'm used to working with. But it still should all come down to triangles and solving triangles once you get to the final step. All right. Well, Mikhail, is that how you pronounce your name, Mikhail?
That is how I pronounce my name.
Good luck to you on this test. I'd be happy to help you in the future if it's more from a pure mathematics rather than a geospatial science. I'm afraid I just don't have the expertise you need
Sure.
to solve
All
something.
right.
Okay?
All right. Well, thanks so much anyway, and I'll definitely be getting back to you here in the future. And my mom said she'll send a check as soon as possible.
Okay, and then you can close out of this session by just clicking on the X of your GoToMeeting panel, and that gets you out of the meeting.
All right.
Okay,
Well,
you
thank
might
you.
get kicked out when I close it out, so I'm not sure, but if it stays up, just click on that X in the control panel.
Okay.
All right, Mikhail. Good luck to you.
Thanks again. I appreciate your help.
Sure, bye-bye.
Bye.